All right, ladies and gentlemen, I am going to start recording our lesson. So, let's talk about the homework solutions.
Let's talk about the homework solutions.
So we have no solution, one solution, at x equals 2.
Pretty sure I copied and pasted the same graph, but changed the equations up there, so my fail. And then one solution, no solutions, two solutions at -3 and 4. So that was all you had to do for the front. On the back, you had to do a little bit more. You had to actually graph those and find me the roots. So in the first one, your vertex was at 1/2 -6.25. And then you got that your roots were at -2, 0, and 3, 0. You could also have written it as x equals -2 or 3. Okay. And then for the next graph, you have your roots, your zeros, and your intercepts. You had to graph that once again. So when you graph that, you were able to see exactly what you were looking at. Okay. And then down here at the bottom are our last two graphs. So number 3, unfortunately, was kind of off your page. Sorry about that. Okay. And then the last example. Okay. And then on the next page, for this one, you had to graph. So you had your graphs on the front. So what I do is set it equal to 0, find my vertex, graph, find my roots. Again, vertex, graph, roots. And down at the bottom, and on the back. So on the back at the top, that was probably pretty easy for most of you. You just have to look at the table, look for the change in signs, and then identify where the roots were between. And then for the very, very last one, you had to create your own table. So I kind of constructed the table both ways. I did it the way we're used to seeing it this way. And then I also did it across. So the idea is that our old table, this is our vertex. And the idea is that the y values are symmetric. So if it's negative 3 on the right, it's negative 3 on the left. If it's 0 on the right, then the next point over here is 0. 5, 5. I apologize. I tried to keep it even, and apparently I added an extra box. So I didn't make you guys go out more than those 3, so you didn't need that one. And then because there are zeros in my tables, those are my actual roots. So this wasn't a between because we had actual zeros. And what you can notice is it goes positive 0, negative, negative 0, positive. So you can see that change in sign around the zeros. Any questions for me on that graph? Table, homework, etc. No, we're okay? All right, then let's look at the packet you just picked up for today. Okay. So we're going to do the front of this handout together as kind of like one last set of reviews to make sure we are okay with each of these problem sets, make sure we're okay with the ideas and what is happening with them. So just like before, this is standard form. So you have your A, your B, and your C. So the axis of symmetry is x equals negative b. So in this case, it's a negative 4 all over 2 times a, which is negative 3. So for your ALS, you get x equals a negative times a negative, which is a positive 4 over a negative 6, which is truly a negative 2/3. The max or min will occur when you plug negative 2/3 into your equation. So you take negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. So you take negative 2/3 squared. That gives you a positive 4/9. Multiply that by negative 3, and you get negative 4/3. Here, a negative times a negative is a positive 8/3, and then 6. So negative 4/3 plus 8/3 is 4/3. 4/3 plus 6 gives you 22/3. Which is approximately 7.3 repeating. So again, remember, we don't care so much about a perfect graph. We care more about finding the roots right now. So you're going to go over to your graph. And honestly, to make this a little easier, I'm just going to make my graph go by halves. So this would be negative 1. So that would be like negative 2/3 is somewhere in here. And I'm going to go up to 7.3. And then the idea is that this also has a y-intercept at 0.6. I know that because it's the c value. So I know I'm going to have a point over here at 0.6. So that's kind of like down 1 and over 1.5 blocks. So we can go down 1 and over 1.5 blocks over that way. And then this graph is going to have a max because of the negative on the A. It's open down for that reason. The max is always at K, so it's at 22/3. My domain is always all reals. My range is going to be less than or equal to 22/3. So plot your points around that. So we already know that like we kind of have this point here at 0. We have this point here at like negative 1.5. So we could make our table, or as shown in the earlier group, if you don't like fractions, you can actually plot any points on your graph by simply plugging in those values. So if I know what 0 is, I kind of know what negative 1/3 is, I kind of know what negative 1 is. Maybe I plug in positive 1 to find a point over here. So you just plug 1 into your equation and find a value. You don't always have to make that table. That table just makes your graph symmetric. But you can technically plug in any number you want. So you get negative 3 minus 4 plus 6. So that gives you negative 1. So what that means is I have a point at 1, negative 1. Oh, it should be over 1, sorry. Because I went by halves. Okay. And then so maybe I want to plug in negative 2. So you find y of negative 2. So you have negative 3, negative 2 squared, minus 4 times negative 2 plus 6. So negative 2 squared is 4. 4 times negative 3 is negative 12. Negative times a negative is a positive 8 plus 6. So 8 plus 6 is 14. 14 minus 12 is 2. So that point hasn't quite crossed below the x-axis yet, so you gotta go a little further. So maybe you go over to y and you go to -3. And you do the same thing, -3 times -3 times -3, minus 4 times -3 plus 6. And now you get -9. So we can see that we have 2 roots, and that they're approximately, that was not very, between 0 and 1. As well as between -2 and -3, which I also got from that data there. So that's why I was saying, like, if you don't make your table like we've been making your table, your points aren't going to be that same symmetry that they've been making. The only reason I did it this way as opposed to the table was because the fraction of the vertex, and just trying to show you that technically you can plug in any number at any point and get a table value. I teach the table because it makes your points symmetric. So like, we'll do the table for the next one, and you'll see how my points aren't so lopsided. Because basically what's happening is you're kind of guesstimating what's happening between these kind of lopsided points now. That's all. But nobody likes fractions, so I wanted to show you a way to do it without fractions. No. I just was trying to provide an alternative method for students that want to see it. Like, I'm going to go back to doing the way I've been doing it with you for this one. So here you'd have x equals -b divided by 2a. So you get negative over a negative, which is a positive. You get 2 over 4, which is really a positive 1/2. And then you plug 1/2 in to find your other vertex value. So a half squared is a fourth. A fourth times -2 is back to -1/2. A half times a half is 1. So you get -5, 0.5 plus 1, which is -4.5. So what that means is my vertex is at 1/2, -4.5. So that's not truly all that bad. And once again, you could do your x's by halves. So it'd be like 1, 2, 3, 4, 0, -1, -2. So you'd have positive a half, and then go down 1, 2, 3, 4 and a half. And again, you could go back to the table we used to do, which was x plus h, ya plus k, and then also 0, 1, 4, negative 2, minus 4.5. Sure. No, you don't have to write it all off to do your calculator. I do it for kids that don't like calculators. So you'd have 1.5 and negative 6.5. And again, that's over 2 dots and down 2 dots. So you do the same here. Go over 2 and down 2 to keep it symmetric. Oops. Your y-intercept is negative 5, so you know you at this point here, which is also there. So here's my graph. And we can see from this graph it's open down. Is that ever going to hit the x-axis? No. So this is a case of no solution. So that graph has a max at negative 4.5. Your domain is all reals. And your range or your y values are going down, which we can see from that graph. So it's y is less than or equal to negative 4.5, etc. And then, go ahead. They're between. So like we wrote roots between 0 and 1, as well as between negative 2 and negative 3. Because when we did our numbers over here, we saw like the 2 and the negative 9. So that meant that there was a root between them. And then over here, you had the negative 1 and the positive 6. So that meant that there was a root between them as well. And you could kind of see that from your graph here also. No problem. And then the last thing, this was more from me grading your quizzes the other day. And one of the first questions was about like being able to write it in vertex form. And that was something it seemed like we struggled with. So the A value is what's on the x squared, the B value is what's on the x, and the C value is what's here. So the A value in vertex form stays the same. You have to find h and k. H is always negative b divided by 2a. So in this case, positive 2. K comes from plugging that in. So that means my h is 2, my k is negative 1, and my a is negative 1. So vertex form is y equals a x minus h squared plus k. So then you just fill in your a, your h, and your k. So the next worksheet is technically your homework for tonight. It's due on Monday along with the next page in this packet. Tomorrow, I want to just review. Your quiz is going to be on Monday. On all of this. So really the only thing that's new from what we've done before to Monday is adding in the roots. I do have your quizzes. I did update your grades yesterday. I put in your quiz scores. So I did want to congratulate a lot of you. I had, I think, more than half of our class got A's on the quiz I put in yesterday. Or